Hello, Science 9 class, Mr. Lum again. We're going to be moving on from static electricity, and we're going to be talking about electrochemical cells, and we're going to be talking about current electricity. So this week we're going to be looking at just some definitions to get a few things before we start talking about current electricity. And it's unfortunate that we can't have regular classes because normally I teach this entire unit just doing labs with batteries and wires and lights and switches and little motors and all that kind of stuff. And you learn through doing it all. So we're gonna have to do it a little bit differently. Anyways, first we have to get through some definitions. So the first thing that we're going to talk about is the term electrochemical cell. An electrochemical cell, we can kind of, understanding the English language, we can kind of dissect the word electrochemical cell and figure out what does that mean. So electrochemical cells, we know that the word electron, electric or electrical, so we know that kind of coming from there. And I think we should understand what chemical means. Okay, so things on the periodic table, you know, your lithium, your nickel, your lead, and all those kind of different chemicals and elements there. And we'll talk about what a cell is in a little bit. But an electrochemical cell is, it takes chemical energy and converts it into electrical energy. So chemical energy is changed into electrical energy. And if you take chemistry 12, we go into this quite in depth, but if you have, when we talked about how reactions occur before in our chemistry unit, you may have heard about when like sodium Na has one electron on the outside shell. Okay, so normally it has 2 and then 8 electrons, and then it has like 1 electron way out there. And lithium has 2 electrons and then has 1 electron right here. And when lithium turns into Li plus, that 1 electron goes away and combines with something else, and then we're left with here. Now that 1 electron flies off and combines with another element. Okay, so but when that 1 electron flies off, if we can kind of harness that energy, and same with sodium, if that 1 electron flies off there, if we can harness that energy, in other words, if we know that electron is going to be leaving, can we get that electron to leave in a very specific direction so that we can harness that energy or that electron leaving and harness the energy that's coming from that electron leaving? And that's what essentially what electricity is. So when you have what we would normally call a battery right here, there's a whole bunch of chemicals inside of it. And what we can say from these chemicals is that these chemicals inside want to react, but they're unable to react with each other inside this battery. But if we connect a wire that goes from one side to the other side, then they're able to react. It is able to send its electron to this side if it can let this electron leave one side and it goes through the wire. And as it goes through the wire, we may stick a motor there or a light bulb there, and it'll do a little bit of work for us by turning on the light or making the motor run. And then it'll get rewarded by allowing that electron to return and react with something else. So all we're doing with electrochemical cells is we're taking chemical energy and making sure those electrons travel down a very specific path for us to do some work. Okay, and we're harnessing that the electron that is being moved around in there. Okay, and so that's what electrochemical cells are. We're just taking chemical energy and converting it to electrical energy. In electrochemical cells, chemical energy separates the positive and the negative charges. So in other words, like, you know, essentially your electrons, and the ends of the battery what we would normally call a battery are called terminals. So this is one terminal, and then down here is another terminal for this type of battery. If we had like a car battery, if you may have seen car batteries, if you're helping your parents work on their car, these would be called the terminals right here. Okay, if you had a 9-volt battery, okay, you usually have one large terminal and then a smaller terminal. These would be the terminals right here. Okay. Now the term energy is the ability to do work, and kinetic energy is, well, kinetic means moving. So is energy, kinetic energy is energy something has because it is moving around, so moving energy. Potential energy is the energy stored in the object. So for example, when electricity is moving, since those electrons are moving through the wire, that is called a type of kinetic energy. When the electricity is just being stored as chemical energy, not being used, just being stored, that would be considered potential energy. And they'd be all both considered types of energy. So electrical potential energy is the energy stored in a battery. Then the electrons have the ability to do the work. So for this course, all of our potential energies that we're going to be talking about are electrical potential energy, the one that's stored in the battery. Here's a picture of a car battery. Okay. Now, in English, we typically say a battery, but in science, we're supposed to call this a cell. Okay. So an electrochemical cell, this is one device that produces electricity. We would call it a battery, but in physics, this is called a cell. A battery is when you have two or more of these connected together. Then it's called a battery. Okay, so if you just had like one Duracell, technically this is called a cell. Once you get a couple of them and you hook them up together, then it is called a battery. Now, the electrodes, these are the metal pieces that come out. So these are essentially equivalent to your terminals. Okay. So the terminals here would be, there's one terminal and there's the other terminal. Now the electrolyte is the stuff or the fluid inside of the cell. So typically car batteries are filled with like an acid in there. Usually it's sulfuric acid in there, and they'll have other components too, like lead and stuff like this. For like the battery that's on your cell phone, it's a little bit different, and we're going to be talking about that in a second, okay? But the electrolyte is usually the fluid that can conduct electricity, and it's inside one of these cells. Okay, now there's two different types of cells, a dry cell and a wet cell. So a dry cell, it has, well, its electrolyte is kind of dry. And when it's dry, like if you cut open a dry cell, like a cell phone battery, and you should never do that, by the way, it's quite dangerous. But if you were hypothetically like have that cut open, it wouldn't leak out everywhere. It would be a moist kind of paste, like maybe toothpastey in consistency, or like a wet sandy kind of inconsistency. But that would be considered what is a dry cell. Compared to a wet cell, it'll be liquid that would flow kind of like water. But it wouldn't be, it'd usually be like sulfuric acid or very corrosive acid. So again, you should never cut open a battery. Now, there's some pros and cons to these. So first off, a dry cell is usually found in all your electronics, kind of things like your cell phone, laptop, Yeah, and a lot of your electronics, things like that. Okay, now your wet cells, these are usually your typical car batteries. That's where you find these things. Now, and we'll get into that because that's kind of changed in recent times. But there's some pros and cons to all of these. So first off is uh, what is the pros and cons of, or what are the differences between dry cells and wet cells? Again, so the biggest thing is, and this comes from the name, is that dry cells, the electrolyte is kind of dryish. It's kind of like a paste, and a wet cell, the electrolyte is liquid, and that's why it's called a wet cell. Wet cells are usually cheaper, okay? And that is a very big plus for wet cells. Um, However, dry cells, they can work upside down. So your cell phone will work in whatever manner that you're holding it. If it's upside down, right side up, left or right, it'll still work, okay? Because that liquid won't kind of leak out or any of that kind of stuff. One of the problems with it is that dry cells are quite expensive. Now, wet cells, they should never be flipped upside down. You could get things like leaking out, like the sulfuric acid leaking out of there, or some problems with that. Now, we typically use these in car batteries because the idea is that your car will always stay upright or relatively upright. If your car is ever upside down, you know, your least of your worries is my battery is probably leaking out. Okay, you have a lot bigger problems than if your car is upside down. So now, with that being said, is that for electric vehicles, when I talk about car batteries and having wet cells, this is for your gas-powered car. So gas-powered cars do have usually one or two car batteries or wet cells in them to get the motor starting and a few other little things like that. For electric vehicles, they pretty much have a lot of dry cells. Okay, it's all dry cells to get the power out of it. There's a bunch of different reasons for that we're not going to really get into, but these are some of the definitions that we're going to need for us to start our current electricity. So your quiz is going to be a lot on these definitions. So if you don't understand some of these definitions, you might want to send me a message, or you can bring up that topic in the group chat for Microsoft Teams, and try doing that before you write your quiz. But this is going to be our kind of starting point for starting current electricity.